Design procedure on combinational circuits, analysis of combinational circuits with example, and also I'll give the introduction about sequential circuits, types of sequential circuits with example. Introduction to ALU. ALU stands for Arithmetic Logical Unit. I think we all are familiar about this. It is a digital circuit that perform arithmetic operations like addition, subtraction, and so on. And also it will have the logical circuits, which is the which performs and, or, not, and other operations. John von Neumann proposed the ALU in 1945 when he was working on EDVAC. An ALU is a fundamental unit of any computing system. Understanding how an ALU is designed and how it works is essential to building any advanced logical circuits. Using this knowledge and experience, we can move on to designing more complex integrated circuits. As we know, CPU is the heart of the computer, ALU is the heart of a processor. You could say that anything else in CPU is that to support the ALU. Here you can see a block diagram of ALU. This is the typical schematic symbol of an ALU. This diagram shows A, B, D, R and F. A, B are the inputs to the ALU, whereas R is the result or the output. F is the code or instruction from the control unit. D, the output status. The output status is completely different from the output or the result. Here it indicates cases such as carry in, carry out, overflow, division by 0, and so on. The types of logical circuits in ALU are combinational circuits and sequential circuits. So now I'll explain what is combinational circuits. Combinational circuits are made of logical gates. It does not contain memory element. That's why they cannot store any information. The value of present output is determined by present input. Examples of combinational circuits are half adders, full adders, subtractors, and so on. So here you can have a look on the block diagram of combinational circuits. So n input variables, when it pass into the combinational logical circuit, it will produce m output variables. That means here you can have another look of combinational circuits based on ALU. The blue colored lines, that is bidirectional lines, indicates the bus. So it is a connecting circuit which will connect to all the components in the computer. X input, Y input, or the two input taken here with K number of bits. K input and K input for either X and Y are taken as a number of bits in X and Y, and here you can have a signal with flags. So when it is enabled, appropriate operator will be taken. That will be given by the select circuit. Finally, after taking the operator, it will perform the operation and it will give the output in result. Again, that is connected to the bus. Either it can leads to storage the result of it. And ALU using combinational circuits is also explained in this diagram. You can see K bit input either in X and Y. It is taken into the select subunit where we can select the appropriate operator. So after selecting it, it will perform the operation related to it and it will produce the output. So when there is a possibility or requirement to perform all the operations or multiple operations, all the output will be multiplexed and a single output will be given as the output from the multiplex. That is taken through the data bus. Here, lot of examples of combinational circuits are listed over here. Let us have a look. Multiplexer, demultiplexer, encoder, decoder, half adder, full adder. Multiplexer and demultiplexer. A multiplexer is the combinational circuit where binary information from one of many input lines is selected and directs it to a single output line. So whenever you are collecting lot of inputs and you are performing some operations using combinational circuit, finally you will be having only one output at the end. Whereas demultiplexer is the reverse process of multiplexing. That is, a demultiplexer is a combinational circuit that receives information on a single line and transmits this information on 2 to the power of n possible output lines. Next is the encoder and decoder. Encoder is a combinational circuit that produces the reverse function from that of an decoder, whereas decoder is a combinational logical circuit that receives code information on n input lines and feed them into maximum of 2 to the power of n unique output lines after conversion. Half adder and full adder. A half adder is a combinational circuit that performs the addition of 2 bits. Full adder, this is an adder. It is little more difficult to implement than a half adder. The main difference between half adder and a full adder is that the full adder has 3 inputs and 2 outputs. A design procedure of combinational circuit. This procedure involves the following steps. The problem is stated. The number of available input variables and output variables are determined. The input and output variables are assigned with letter symbols. Truth table is drawn. Boolean function for output is obtained. Finally, we will be giving the logical diagram for it. Analysis procedure of combinational circuit. To determine the output functions as algebraic expression, it is a reverse process of design procedure. A logical diagram of the circuit is given, then obtain the truth table from the diagram, obtain Boolean function from the truth table for output. So here I can explain more detail about the adder. So before going to adder, so here is an example that shows how binary addition is done manually. So here I am having 4-bit number. So one is augment, another one is addend. Both the numbers are added, and if so, you know the formula for adding binary element. If 1 plus 1, it will give 1 0. 1 plus 1 plus 1, it will give 1 and 1. So you will be having some carry for this. So based on the normal binary addition, we are going to perform with 4-bit number. So the value of one number is 1011, another number is 1110. This is a binary number. First I am adding 0 plus 1 or 1 plus 0. I will be having the sum as 1. So to perform binary, we will be having the sum, carry in and carry out. So let me explain what is carry in and carry out. So here you can see in this example I am adding 1 plus 1. So I will be having 1 0. So I am placing the 0 here, 1 as a carry. So this is called the carry in. So finally I will be having double 1 and 1. So I am placing the 1 here, and final 1, that carry in is placed here. This is called the carry out. This is also called as most significant bit. and this one is called the least significant bit. So the same binary addition is performed by using half adder. So this is a circuit which is going to perform addition of two numbers. So let the number be x and y, which has 2 bits. The possible values is given in the truth table. If it is 2, if we are having two values, the possible values might be 0 1, 0 0, 1 0, 1 1. So if I am having the value like this, the sum will be 0. If 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, I will be having 1 0. So I will be having the sum as 0, 1 as carry. So that is given here. So for this, here, this is the expression obtained. So to derive the expression, I will be taking the variable related where I have 1 in the truth table. So here I am having the value as 1. So here I am taking this value x dash y plus x y dash. So it is given as s is equal to s x dash y plus x y dash. Whereas in C I am having only 1 is here. So C is equal to x y. Okay. So this is implemented in the logical gate also. The same way we can implement full adder using 3 bits. So here you can see the example. So to perform addition of 3 bits, the most possible ways of arranging the value of bits is given here. It is explained here. You can see that the possible ways of 3 elements. So the same way as we calculated the sum and carry out is calculated here also. Then we will be deriving the Boolean expressions. So finally S is equal to x exclusive OR of y and exclusive OR of C in. Okay, the same way C out is equal to XR of y C in plus XY. So full adder circuit. We write the equation this way to highlight the hierarchic nature of adder circuits. You can build a full adder by combining two half adders. So this is one half adder and this is another half adder. So by combining this, I can get a full adder circuit. So this explains about how we can add 4-bit addition by using full adder or half adder. See here I am taking only 2 bits, so I can perform this by using full adders. See here I am taking the value of A in 4-bit form, that is A0, A1, A2, A3. Similarly B0, B1, B2 and B3. At first stage I will be having the carry 1 with 0 because initially we won't be having any carry. So either we have the carry or not, we should have the value C1 as 0 with A0 and B, and we will perform addition over there. We will be having some result, so that is given as S in S0, and the carry of that addition will be taken as C1 again to A1 and B1. Again there will be performing addition, the result will be stored in S1. Respectively we will be getting the value of S0, S3. The final carry out will be stored in C0. You can see here. So here we can see an example of 4-bit addition. See, the value of A is given as 1011 and B is 1110. This is a binary number. So I am going to perform addition with these two numbers. So initially I am having the carry as 0 in Ci, and the value first bit of A is taken as 1 for A and the first bit of B starting from the right hand side I'm taking as B0 0, and if I perform addition I'll be getting the value as 1. So I have no carry here, so C1 holds the value 0. Respectively I'll be adding all the thing and finally I'm getting the carry out as 1. Now let us move on to sequential circuit. Like combinational circuit, sequential circuit is also a circuit which is made up of combinational circuit and with memory element, whereas in combinational circuit we won't be having any memory element. So this is a major difference between sequential and combinational circuits. The memory element are devices capable of storing 1 bit information. One output depends on input and previous state. Examples of sequential circuits are flip-flop, counter, shift register and so on. So let us have a look of the block diagram of sequential circuit. So here input is taken to the combinational circuit with memory element. Okay, so the combinational circuit will process the input as well as the element of memory and then it will produce the output. So this diagram will also give you more detailed information about the sequential circuit. So a k bit or x value and k bit y value is taken. So here based on the select and control, it will select the appropriate operator and then the result will be produced after processing, and through the database the result will be taken out. The same thing is explained here. So x has the k input and y has the k input bit. So both variable have whatever value they have, they are taken into consideration, and by using the select line the appropriate operator will be taken to perform the operation. The result will be obtained and it will be taken through the data bus or bus. The examples of sequential circuit are flip-flops. In flip-flops we will be having JK flip-flop, RS flip-flop, PR flip-flop, D flip-flop, and one more is left out here, that is T flip-flop. And apart from flip-flop we will be having registers and counters. Flip-flops are the basic building blocks of sequential circuit. A flip-flop is a binary cell which can store a bit of information. A basic function of flip-flop is storage, which means memory. A flip-flop, which can be denoted as FF, is capable of storing 1 bit of binary data. It has two stable states, either 1 or 0. A flip-flop maintains any one of the two stable stages, which can be treated as 0 or 1 depending on the presence and absence of the output signals. Registers and counter. A circuit with flip-flops is considered as a sequential circuit even in the absence of the combinational circuit. It is not necessary that the sequential circuit should always have the combinational circuit. Without combinational circuit also called as a sequential if it has a flip-flop. Circuits that include flip-flops are usually classified by function they perform. Two such circuits are registers and counters. Registers. It is a group of flip-flops. Its basic function is to hold information within a digital system so as to make it available to the logical circuits during the computing process, whereas counter is essentially a register that goes through a predetermined sequence of states. Types of sequential circuits. So in sequential circuit we are having two types, that is synchronous sequential circuits, asynchronous sequential circuits. Synchronous sequential circuits. In synchronous sequential circuits, the states of the device changes only at discrete time in response to a clock pulse. In a synchronous circuit, a electronic oscillator called clock generates a sequence of repetitive pulses called clock signal, which is distributed to all the memory elements in the circuit. Asynchronous circuits. Asynchronous circuits is not synchronized by a clock signal. The outputs of the circuit changes directly in response to the change in the input. The advantage of asynchronous logic is that it can be faster than synchronous logic because the circuit does not have to wait for a clock signal to produce inputs. The speed of the device is potentially limited only by the propagation delay of the logical gates used. Design procedure of sequential circuit. This process involves the following steps. Make a state table based on the problem statement. The table should show the present states, inputs, next state and outputs. Assign binary codes to the states in the state table. If you haven't already, if you have n state, your binary code will have at least log2 n digits and your circuit will have at least log2 n flip-flops. For each flip-flop and each row of your state table, find the flip-flop input values that are needed to generate the next state from the present state. For example, at present you are having the state as 0 means the next state will be 1. Likewise, you will be generating the next state. You can use flip-flop execution tables here. Find simplified equation for the flip-flop inputs and outputs. Build the circuit. Likewise, we can build the sequential circuits. So here is an example which shows the logical diagram analysis. So here we are having three variables A, B, C. With that we are calculating T2, T1, T3 and finally we will be getting the output as F1, F2, F3. Sorry, F1 and F2 and also F-2. Based on the circuit given there, the Boolean function for outputs are T1 equal to A plus B plus C, T2 is equal to ABC, T3 is equal to F2 dash of T1. The output function for gates are F1 and F2. So by using theorems as well as simplifying methods, we can simplify it and finally we will be getting the output as A dash B C dash plus A dash B dash C plus A B dash C dash plus ABC. And for this we will be developing the truth table. So we will be having the three variables A, B, C with the possible values starting from all zeros, finally ending with all 1. The value of T1, T2, T3 is taken from the logical circuit diagram and also F1 and F2, F2 dash. That's all about combinational circuits and sequential circuits. If you have any queries, please contact to my mail ID. Thank you very much. And please go through the reference that is prescribed here, and also you can go through the textbook. Thank you.